Hello, today we're going to be looking at the mini lesson for lesson 7.4, which is solving proportions. If you think back to lesson 7.1, we talked about proportionality whenever we mentioned that equivalent ratios form proportions, and we talked about several ways to determine whether or not two ratios are proportional. So in example 1, that's just a review of that. The two main methods we discussed were either simplifying the fractions all the way, or finding a common denominator. So we're going to do one of each here. So for A, we're going to go ahead and simplify both fractions. So if we start, let me just zoom in a tiny bit here. If we start with 8/24, I know both are divisible by 8, so I'm going to go ahead and divide by 8, and that's going to give me the fraction 1/3. For 6/22, I know both are divisible by 2, and that's going to give me 3/11. So very quickly I can see they're both in simplest form. They're clearly not equal. So we would declare that no, these are not proportional. On the other hand, we could find a common denominator. So if you take a look at letter B, we notice that the least common denominator between 20 and 80 is 80 itself. So we wouldn't need to change the second ratio at all, but we could take the first ratio and multiply it by 4 on the top and the bottom. If we did that in the numerator now, we would have 20. In the denominator, we would have 80. And we can see that that is identical to our second ratio. And that confirms that these two ratios are in fact proportional. Okay, now because we know that this relationship exists, we also then can use this property to determine a missing piece of a proportion. So if you look in example 2, letter A, we're missing part of the 1 ratio. We can see that there's a relationship that exists between the denominators, however, and so if you can recognize that, that can make the solving process much easier. So I recognize, for example, that if I multiply the denominator of the second ratio 3 by 3, I would get to 9. So whatever I do to the bottom, if I also consider doing that to the top, then I would multiply 11 by 3, and I would find that P would equal 33 in this case. So that's one way that you can definitely do it. Now in this next one, we notice that to get from the numerator 3 to 15, we would have to multiply by 5. So if I do that in the denominator as well and multiply 4 by 5, I would find that x is 20. So to find missing pieces of a proportion, if you know that they are in fact equal, you can just simply find a common number to multiply by. Now sometimes that won't be quite as easy. So if we take a look down at example 3, we're going to look at another method that could be used here, and that's called cross products. So anytime we have two ratios that are considered to be equivalent to one another, what else happens is a pretty cool feature is that if we find the product of the diagonal values, they actually will be equal to the product of the other set of diagonal values. So their cross products are equivalent. So that allows us, that property allows us to solve this in a completely different way. So in letter A here, if I multiply 14 by x and I multiply 9 by 7, I would get the equation 14x equals 63. So then it's just like a normal one-step equation. I would divide by 4. And if I divide 63 by 14, we get an answer of 4.5. And so x equals 4.5 is your answer. Now we can use cross products again in letter B. So if I multiply diagonally, 4 times y would give us 4y. 3 times 12 would give us 36. Then from there I can undo the multiplication by dividing both sides by 4. And I will quickly see that y is equivalent to 9. So it really doesn't matter which method you choose. If you can see quickly that multiplication works, then go for it. If it's not as obvious to you, then maybe use cross products, and just know that you'll set the two cross products equivalent to each other and then solve for the variable. Okay, in example 4, we're going to be setting up our own proportion. It says that Vanessa's baking pies with her mom for Thanksgiving dinner. If the recipe calls for 7 cups of filling for 2 pies, how many cups of filling are needed to make 7 pies? So what we want to do when we set this up is make sure we're putting the correct unit on the top and the bottom. So it doesn't really matter how we start, but it just makes sure we want to make sure we set it up correctly. So if the recipe calls for 7 cups of filling for 2 pies, we could go ahead and put 7 cups for every 2 pies. And then we want to know how many cups of filling would be needed for 5 pies. So that means X would go up in the numerator with cups, and the 5 pies would go in the denominator. So I think for this one, cross product seems to make the most sense. So I'm going to go ahead and cross multiply. So I would get 2x is equal to 35. And now I would go ahead and divide both sides by 2. And we would get an answer of 17.5 cups. Make sure if it's a word problem, you do label your final answer. But we were able to quickly figure out that answer just using cross products. Okay, thank you.